Here we're going to graph exponential functions using transformations. So we're not going to be creating a table of values, we're going to be using transformations. So before this video, you should review the video Transformations of Functions. It's a pre-calculus algebra video we've talked about, and there are two parts to this, parts 1 and part 2. And we're going to be using the transformations mentioned in those videos here in this video now. Let's go ahead and jump right into an example. So let's graph this function f of x equals 2 to the negative x plus 3. Okay, so when you look at an exponential function, you want to sort of recognize the underlying basic exponential function. In this case, it would just be y equals 2 to the x. So we're going to graph y equals 2 to the x on the left, and the idea is that we're going to apply transformations to that graph, or apply one transformation to get another graph, and then apply transformation to that graph to get our final graph, okay? So what does y equals 2 to the x look like? Well, it's an increasing exponential function. Let's go ahead and graph that in now with a couple of points. So here's the graph of my function 2 to the x, and I've put a couple of points in there. I've put the point 0, 1. Let's keep track of that point. And then I've got this other point 1, 2. So those are both on this basic exponential function graph. Okay, so let's apply a transformation to that. We're going to apply transformations one step at a time and end up with our final function. So the first thing we're going to do is we're going to replace x with negative x. So the function here is going to be y equals 2 to the negative x. And the effect of that, when you replace x with negative x, that reflects this function, the previous function, across the y-axis. So instead of 1, 2, we're going to get negative 1, 2. We're going to get this point right here. So when you reflect across the y-axis, the x-coordinate changes sign. So negative 1, 2, and then of course 0, 1 is going to remain the same and right here. And so if you imagine this function, this graph reflected across the y-axis, the graph is now going to look like this. So let's go ahead and graph that in now. And this would be our graph, right? So we reflected this graph across the y-axis. I should mention as well that here, you know, with this exponential function, we have a horizontal asymptote. Let's write HA for horizontal asymptote of y equals 0. Now, when you reflect across the y-axis, like we did here, you still have the same horizontal asymptote. You still have y equals 0 for your horizontal asymptote. Now, finally, the last transformation to get to the function we're after is to add 3 to this one. So that's going to shift this graph up 3 units. So we have y equals 2 to the negative x, and then plus 3. Now, it's going to shift everything up 3 units, the entire graph, but the horizontal asymptote is going to shift up 3 as well. So we're going to have y equals 3 being our horizontal asymptote. So tracking these points, let's see, this point remained 0, 1. Okay, this point we said the x-coordinate became negative, so it was negative 1, 2. And then for the final graph, what you do when you add 3 is you add 3 to the y-coordinates. So instead of 0, 1, you're going to have 0, 4. You're going to have the point up here. Let's label that. So that point's going to be 0, 4. And then this point, if you add 3 units to the y-coordinate, it's going to be negative 1, 5. So negative 1, 5 is going to be way up here. Okay, let's label that. So negative 1, 5. And so the graph is going to look like this. Now, of course, the horizontal asymptote is going to go through 3. So let's draw those in now. So there's our final graph. It's basically the graph we had before, but shifted up 3 units. So it's still decreasing. And now, of course, I've drawn in the horizontal asymptote y equals 3. So the graph is approaching, the y-coordinate is approaching 3 as x goes to infinity. Okay, let's try another one like that. Let's graph y equals 2, take away 3 raised to the x minus 1. And so I've created 4 templates of graphs because I know that I'm going to apply I'm going to need 4 transformations. Now, when you're doing these problems like in homework, you're not sure how many graphs you're going to need, but it's always nice to create carbon copies of your coordinate systems and then go ahead and apply one transformation at a time until you get to your final function starting from your original function. So what would be a good original starting function here? You're looking for a basic exponential function. In this case, it's just going to be y equals 3 to the x. That's going to be the starting simple exponential function. And we know the graph of that is simply an increasing exponential function. Let's go ahead and draw that in now with a horizontal asymptote at y equals 0 again. So this is the graph of y equals 3 to the x. I put in 2 points, 0, 1, and 1, 3. And so let's go ahead and apply a transformation. Now the first thing we're going to do is we're going to replace x with x minus 1. So we have y equals 3 raised to the x minus 1. And the effect is when you replace x with x minus 1, that shifts the previous graph 1 unit to the right. So instead of 0, 1, we're going to have 1, 1. Let's draw that in. And instead of 1, 3, we're going to have 2, 3, which is up here. And you're still going to have the same horizontal asymptote. Let's go ahead and graph that in. So it's going to look like this. So this is the graph of the function. This graph has been shifted to the right 1 unit, and I've labeled the points 1, 1, and 2, 3. Okay, so now we're going to transform this graph. So what do we need to do? We need to multiply it by a negative 1. So the graph down here is going to be y equals negative 3 to the x minus 1. And what's the effect when you take a graph or a function and you multiply it by a negative? The answer is it reflects the graph across the x-axis. So instead of 1, 1, we're going to have 1, negative 1. The y-coordinate's going to become negative. So 1, negative 1. And then instead of 2, 3, we're going to have 2, negative 3 right here. Let's label those points. 2, negative 3. And this point we said was 1, negative 1. Let's fix that so you can read that negative 3 there. Okay, so if you reflect this graph across the x-axis, it's going to look like that. So our graph is going to look like this. Let's go ahead and draw that in. Notice that the horizontal asymptote is still y equals 0. So here's our graph. It's concave down, we say. So this graph is the reflection of this graph across the x-axis. And then finally, the last thing we need to do, the last transformation we need to apply, is we need to add 2 to this to get to our final graph, the one we're interested in. So y equals, well, it's negative 3x minus 1 plus 2, but you can also write it as 2, take away 3 raised to the x minus first. And so the effect is it's going to take this graph and simply add 2 to all the y-coordinates. That's going to mean the graph shifts up 2. So instead of 1, negative 1, we're going to have, we'll add 2 to the y-coordinate. It's going to be 1, positive 1. So right there. Instead of 2, negative 3, it's going to be 2, negative 1. So right in here. And one interesting point as well, that instead of the y-coordinate or the horizontal asymptote being at 0, now we're going to have a horizontal asymptote at 2. So I'll have a horizontal asymptote like this, and the graph is going to look like that. Okay, so let's graph that in now. And this would be our final graph. So the graph is basically the graph that you had before, just shifted up 2 units. And now we have a horizontal asymptote at y equals 2, which I wrote in right here. So we have a horizontal asymptote at y equals 2. Okay, so the key to graphing using transformations, and you're going to apply this for exponential functions or with trig functions later on, but the key is really knowing your basic transformations and then building up from basic functions that you know. All right, until next time.